All right, and welcome back for another installment of Mr. Wojciechowski Teaches Calculus. Yay! So the first thing that I want you to do today is to really try these problems out. Graph y equals sine of x, graph y equals cosine of x, graph y equals negative sine of x, and graph y equals negative cosine of x. You really want to do that. You could use that to sketch the derivative of each function and verify your graphs using nderive. And that's supposed to be, if you're using your calculator for anything today, change it into radians mode and use z-trig. Yeah, so probably a good idea there. Z-trig just changes all your horizontal tick marks to, I believe it's 1/4 or 1/2 pi. Give me a second, I'll figure that out. But before we got there, I did want to show you guys this awesome cartoon. Why are you deriving yourself? X cubed. Why are you deriving yourself? 3x squared. Why are you deriving yourself? 6x. Why are you deriving yourself? 6. Why you... Oh, he's gone. Because he differentiated out. Isn't that awesome? The best kind of jokes are the jokes that you have to explain. So I'm going to pause this. I'm going to let you guys do that. And then come back and we'll start the day. And I'm coming back to you guys right now. I actually have graphed here right now. I have y equals sine of x, y equals cosine of x. They're not exactly the best graphs, but you guys know my artistic ability is not the absolute best. And we just wanted to use this to kind of estimate what the graphs of the derivatives are going to look like. So if I was to take the graph of the derivative of sine of x, again, I'm looking for where I have these zero slopes. So zero slope right here, zero slope right here, zero slope right here, zero slope right here. And I can see in between these two zeros, I actually have a positive slope. So that function, that derivative is going to look roughly like this, right? And in between these two zero slopes go down. So I got negative slope right here. Over here I got positive slope, so in between these two zeros, I got it go down, so negative slope. Now compare this brown graph right here to the graph of cosine of x. Just a real simple guess here is maybe the derivative of sine of x is cosine of x. So maybe the derivative of cosine is going to equal sine. Maybe. Let's look. I got a zero slope right here. Zero slope right here. So we'll draw those. 0, 0, 0 slope, 0 slope. In between these two zero slopes, I've got a negative. After this zero slope, I've got a positive. In between here, I've got some positive slopes. Here, I've got negative slopes. Oh, look at that. That actually looks like negative sine. Let's look at the graph of the derivative of negative sine. Zero slopes all around here. Negative slope, so going like this. In between these two zero slopes, go down, so negative. And then between these two zero slopes, go up, so positive. And then negative. Oh, looking at that, that looks like negative cosine. And then when I graph negative cosine, again, zero slopes. Boom, boom. So draw them, draw them, draw them. So now I'll have positive slope here, so up. Negative slope, so down. Not worrying about magnitude too much here. Positive slope, so up. Then negative slope. Oh, look at that. We've looped right back to sine of x. So that kind of ruins like 2 of the rules for you guys today. Oh, wait, here. One other thing that I wanted to show you guys is I actually have my graphing calculator right here. You can see I've got y equals sine of x in the first one. Dx, the ddx of y1 at x equals x when I graph this. Of course, the blue is sine, and then the red comes through, and that's the graph of the derivative of sine, you can actually see it looks exactly like cosine. You could do the same thing for cosine, just to see that we were right about those. We got cosine of x, so graphing it. Cosine's now blue. And look, that's a negative sign. Cool, huh? I think so. I think it's really fun to play with that kind of stuff. And let's see here. Oh, there it is. All right, derivatives of trigonometric functions. So all this stuff right up here that is on my board, this is all the stuff that we did on that, what would have been the do now if we were in person teaching. What we really need out of this is your new rule for today. Well, one of 6 new rules that you have is, whoa, that did not work in my favor whatsoever. This right here, that needs to go in your notes. I would recommend, again, keeping a running list of all of the rules. Just put it on a separate sheet of paper. d dx of sine of x is equal to cosine of x. You need to know that from here on out. Again, stuff we did in the do now, but you need to know d dx of cosine of x is equal to negative sine of x. So it is important that they each differentiate to each other. The co goes to the negative sine of x. So derivative of sine is positive cosine, derivative of cosine is negative sine. And if you continue that cycle, the derivative of negative sine, you're going to have that factor of -1, so the derivative of negative sine would be negative cosine, and then the derivative of negative cosine would be negative sine, which would be positive sine. So you have one of those four term arcs there. I don't know exactly what word I'm trying to think of here, but hey, here's some problems where I have to show you how to find derivatives. These problems you are going to be locked into using the product rule. So remember, in 2 sections ago, we were able to find our way around using product rule by foiling stuff out. You can't foil out anymore. So like if I'm looking at number 1, I have to, in order to find y prime, I need to use product rule. So I need to do the left to right plus right to left. It doesn't matter what order you do it in, because again, this is the product rule. So left to right, x cubed times the derivative of cosine, something that we just wrote down, would be, actually, let's just write it out this way. X cubed times d dx of cosine plus left to right plus right to left. So if I want to write all of my work, that's how I can write all of my work. Really, ultimately, what this gets into, x cubed times derivative of cosine. Again, we just put down that it was negative sine of x. Plus cosine x times derivative of x cubed. I hope you know that's 3x squared. I would clean this up just a little bit. So I would have negative x cubed sine of x plus 3x squared cosine of x. Honestly, if I was doing this problem, I probably would have flipped the order, just because I think 3x squared cosine of x minus x cubed sine of x just looks cooler, but this is your final answer here. There's number 1. You will now be responsible for doing that kind of stuff. Ooh boy, we've got quotient rule. G of x is equal to sine x over cosine x plus 2x. We remember from 2 sections ago, quotient rule, low to high, high to low, low, low. So I've got low cosine x plus 2x to high minus the high de low. Over the low. and just cleaning it up just ever so slightly, we could have, let's see, the quantity of cosine x plus 2x times derivative of sine is, oh, hey, cool, cosine minus sine x times the quantity derivative of cosine is negative sine, derivative of 2 is plus 2, all over cosine x plus 2x squared. You could leave it here if you want to, but I happen to see something that happens that's really cool on this one, so I personally am going to take it a little bit further. Like, I'm going to distribute that cosine so that I've got cosine squared x plus 2x cosine x. Distribute this negative sine of x in, so I got negative sine times negative sine gives me plus sine squared x minus 2 sine of x all over cosine x plus 2x squared. The only reason why I did this is because I see a cosine squared and a sine squared in here, and I happen to remember that those two added together gives me 1. So I would have 1 plus 2x cosine x minus 2 sine x all over cosine x plus 2x squared. That's where I would leave it. However, if I was a scared elementary calculus student, I might just leave it right here. You don't have to simplify anything, it just makes it look prettier. Let's see, some other stuff we might be able to figure out. Number 3, there you have a product rule. Ooh, 4 looks ugly. 4 looks ugly. I would recommend doing 4. 5, that looks ugly. No, actually that doesn't. This looks like a very straightforward quotient rule problem. 6, the only thing that scares me about number 6 is that square root. Should I clean up my page and do a couple? Maybe pause it, try them out. Make sure you're doing these right. There we go. Well, we did 1 and 2 already, right? Oops, that didn't work out too well. So for number 3, again, I see that we got a product rule here. So f prime of x is going to equal left 3x, right, derivative of sine is cosine, plus left to right, right to left. The one thing that I see about how I've left it here, you might want to write it as 3x cosine x plus 3 sine of x. Heck, you could have even gone back here and just looked at 3 as a constant multiple and had this as 3 times the quantity of x cosine x plus 3 sine of x. There's like so many different answers possible on these. Any sort of algebraic manipulation. Ooh, number 4. Anybody see a trick on number 4? I'm trying to trick you on this one. Number 4, we got y prime is equal to low d high, high d low. So our low is going to be cosine x times the d high, derivative of sine, is going to be cosine of x minus low d high, high d low over low, low. And again, I see that cosine times cosine and that sine times sine. I'm going to change this up and put it as cosine squared of x. Oh geez, I did a boo-boo here. Right here. The derivative of cosine, high d low, is not negative cosine. Ugh. it's negative sine. So now I'm going to have negative times negative gives me the positive of sine squared x over cosine squared of x. Now, two things you could do this here. You could split this up into two different fractions, or really the thing that I like to do on this one is call this 1 over cosine squared of x, which the reciprocal of cosine squared is just secant squared. And if you're a real thinker on this one, you'll recognize sine over cosine is the same thing as tangent. You now have a rule for what d dx of tangent is. The derivative of tangent is secant squared. That's fun. Let's do these other two real quick. G prime on number 5 is going to be the, let's see if I can screw this up again, low d high x times negative sine x minus high d low over low low. And just cleaning it up a little bit, negative x sine x minus cosine x over x squared. And I know I've said this before in this chapter, you don't have to simplify anything, although in the future, if you start simplifying now, you're gonna see the benefits later if you practice your simplifying now. If I was to do this last one, I personally just have to think of square root of x as x to the half. Although we have in previous sections said what the derivative of square root of x is, I personally have it memorized. But looking at this one, I know y prime is going to be the left to right plus the right to left. So to left, I'm going to have to take that half down. I got half x to the half minus 1 gives me negative 1/2. And personally, I just think it looks so much better if I write this as square root of x cosine of x, reconverting that rational exponent into a radical, plus I put sine x in the numerator